We are very diverse women from very diverse STEM fields, and we are actually spread throughout the country. We even have a panelist joining us from Puerto Rico today. The one thing that unites us is that we are all AAAS if then ambassadors. So AAAS is the American Association for the Advancement of Science. And a couple years ago, they went out for a search and they found 125 women across the country to serve as role models, and we were all chosen. And so it is our privilege and honor to be role models and do a lot of outreach and talk to a lot of children across the country about the wonders of STEM and STEM careers. You may recognize some of our panelists because the AAAS If Then Ambassadorship is multifaceted. Aside from doing things like the Science Festival and classroom visits, you may recognize some of us from the CBS morning show Mission Unstoppable, where many of us have been featured. You may actually see us across schools and museums across the country because we're all part of what's called the ifthencollection.org, which is the world's largest free digital asset of women in STEM careers that are free for use for classrooms and museums across the country. Very, very excitingly, we are also statues, hence the name of our panel today. So If Then is putting out an exhibit. It will be the largest exhibit of female statues in one place at one time ever in the world. It will feature 122 women in STEM careers, and it's scheduled to be debuted in Dallas, Texas this year. We're very hopeful that with COVID and everything, we're able to make that a reality. So with all of that being said, let me introduce you to today's panelists. Hold on. If I can get this slide to go, that'd be great. Just thinking. There we go. So my name is Paula Garcia Todd. I have a bachelor's and master's in chemical engineering, and I have been in the pharmaceutical industry for 18 years, working on new medicines across the world. I've really enjoyed my career. It's been very fulfilling for me. You can find me on Instagram at WatchMeSTEM. I'm also on Twitter, so I'm happy to connect if you have any specific questions after the event.
And good morning. My name is Aisha Lawrey. I am a STEM educator, an engineer, an electrical engineer. And my background, I got my bachelor's in electrical engineering and my master's actually in public policy and administration. I am currently in nonprofits where I work at NACME, which is the National Action Council for Minorities in Engineering. And I've been doing a lot of this work for almost 20 years now. And so I love just really trying to promote and encourage many women as well as minorities, just about all of the opportunities that are in this field. And you can also find me on Instagram at AKBossLife.
Good morning, everyone. I am Arlyne Simon. I am a biomedical engineer. My undergrad is in chemical engineering and my PhD is in macromolecular science and engineering. As a biomedical engineer, I help create new diagnostic tests, design syringes, and currently what I'm doing is designing new medical imaging equipment like ultrasounds. I also write the children's book series called Abby Invents over at abbyinvents.com. And my mission really is to encourage girls and boys to become inventors. I am an inventor as well. I have 2 patents, and I'm really excited to be here to talk to you today.
Good morning. Hola. My name is Greetchen Diaz, and I'm from Puerto Rico. And I did a biology degree, bachelor and master degrees in biology, and then a doctoral degree in molecular genetics. And right now, what I do is that I work for a nonprofit organization, and I lead projects in education that impact students and also teachers. So I'm very happy to be with you today.
Hi, everyone. My name is Afua Bruce. I'm a computer engineer and public interest technologist. I got my undergraduate degree in computer engineering and then went on to get a master's of business administration. I currently work at a nonprofit called DataKind, where I get to work with volunteers all across the world with nonprofit organizations and governments all across the world on using data science and artificial intelligence in service of humanity. Great to be with you all this morning.
Hi everyone, my name is Megan Prescott and I'm an Atlanta native, so it's good to be here today. I got my PhD in microbiology from the University of Georgia, where I studied the bacteria that causes tuberculosis. And now I work for TED conferences, or TED Talks as you might know them by, and I work for them evaluating their science and technology content. So good to be here today.
Good morning. It's hard to follow that. But hi, everybody. My name is Dr. Danielle Twum. I got my bachelor's in biology and went ahead and got my PhD in cancer immunology. I currently work for a cancer diagnostics company using the technology that Dr. Arlyne Simon invents. And you can find me on Instagram and Twitter at Forged Onyx. I'm very happy to be here.
Hi, I'm Amy Elliott. I got my bachelor's and PhD in mechanical engineering, and I study 3D printing at one of the Department of Energy labs as an efficient way to make things. So I get to play with lots of different types of printers, big and small.
Hi everyone, my name is Dr. Kristen Lear. I am a bat conservationist, so I work around the world to study and protect bats. I got my PhD in integrative conservation, and as an undergrad, I studied zoology, the study of animals. And yeah, I've worked around the world doing different conservation projects with bats, and now I'm at Bat Conservation International, so kind of like a dream come true. And I'm also on Instagram at batsforlife_Kristen and Twitter at batsforlife.
Awesome. Thank you all. So as we can see, we've got an amazing group of ladies here today. What we're going to do today is we're going to play a little interactive game. We're going to play a little game of Jeopardy, if you will. I'm going to show you some of the categories. I'm going to ask questions. I'm going to give all of you at home 5 seconds to put in your answer in the chat. And through this process, we're going to learn a little bit about science. We're going to learn a little bit more about our panelists. So I hope you were paying attention as they were introducing themselves. We'll take it from here. So our categories today are STEM fields, diversity in STEM, breaking stereotypes, STEM facts, and did you know? So with that, let's get started. Our first question is in STEM fields. This type of scientist studies wild animals and how to protect them. Is it a conservationist, an ecologist, or a veterinarian? I'll give you 5 seconds. And the answer is?
Conservationist. Hi, everyone. Again, I'm Dr. Kristen Lear, and yeah, conservation is basically learning about wild animals and learning how to protect them. The animals that I work with are bats, because unfortunately, a lot of bat species around the world are either threatened or endangered. So I study them. I've studied them since college, but I actually got my start much earlier in bat conservation. I got my start in 6th grade when I was 12, when I built and put up bat houses for my Girl Scout Silver Award project. So since then, it's been a lifelong passion. I've gotten to travel the world to places like Australia, Mexico, Hungary, across the United States to study and learn about how we can protect bats. So moral of the story is really whatever your passion is, it is never too early to get started. Thank you.
Awesome. Thank you so much. All right, here we go. Our next question is, this type of engineer designs blood tests and medical devices. Is it a civil engineer, a biomedical engineer, or a mechanical engineer? Put in your answers. And the answer is?
Biomedical engineering. And I saw many of you answer correctly. So I'm a biomedical engineer, and biomedical engineering is all about pairing your love for biology and engineering to create technologies that save lives. So as I mentioned in my intro, I've invented a cancer diagnostic test. I've also designed supercomputers, and right now, again, working in medical imaging, so biomedical engineering.
Awesome, thank you. All right, next question is, this type of scientist studies tiny living organisms. Is it a chemist, a microbiologist, or an entomologist? Let's put in your answers. And the answer is
Microbiologist. You guys seem to have all gotten it right, so good job. So micro, of course, means tiny, and biology is the study of living things. So you guys got that, awesome. So like I said, I studied the bacteria that causes tuberculosis. And the cool thing about studying that is we get to work in these special labs called biosafety level 3 labs. And you have to wear this funny suit, and you get your own air purifier. And that's where you get to work with bacteria that cause infections in humans. So it's also the same type of lab that they work with the virus that causes COVID-19. And so, yeah, there's lots of cool things you can study with microbiology.
awesome. Thanks, Megan. All right, your next question. All scientists do research in a lab. True or false? All scientists do research in a lab. And the answer is
It is false. So I work, for example, as a public interest technologist, meaning I look at ways to use technology to deliver services. So think about delivering medicine and food and making sure people can pay their rent and stay in their homes and things like that. So I work all over the world, and I'm rarely inside a lab.
thank you for that. All right, here we go. Next question. We are now in the new category called Did You Know? And in this one, I hope you were paying attention to our panelists. And if not, just take some wild guesses. Here we go. This panelist likes to change her hairstyle a lot because it should not matter what you look like to be in STEM. Put in your guesses. And the answer is
Yes, it's me. I I honestly, one of the things that really bothers me is that there seems to be an idea of what a scientist should look like, and it's not true. As you can see just from this panel and from also, watching the Mission Unstoppable series, scientists come in many forms and many shapes with different hairstyles. They express themselves in so many different ways. So if you ever think that there is a certain mold for what a scientist should look like, you should completely take that thought out of your mind and come in realizing that you are what a scientist looks like. You are the mold. Every person in your life could be a scientist. So you can be a scientist. Anyone could be a scientist. So
it's amazing, Danielle. Thank you so much. Awesome. All right, next question. This panelist is an inventor. She invented a blood test that detects when cancer patients reject bone marrow transplants. Who do you think it is? And the answer is?
Everybody was correct. It's me. So this was work I did during my graduate school research at University of Michigan. And it took me about 3 years to actually get to the experiments to start working reliably. So sometimes inventing takes a very long time. I know sometimes when you watch TV or in the movies, they show the scientist just working by himself. Usually it's a guy working by himself in a lab with no collaborators. But for me, I had several collaborators. They were cancer researchers, they were microfluidic researchers. So you really need a solid team to be able to vet your ideas. And failure is a part of the invention process. You're going to feel a lot. So you just have to maintain perseverance and diligence and trust that you'll succeed.
Awesome. Thanks, Arlyne. All right, here's your next question. this technology has allowed the COVID vaccine to be made so quickly? Is it DNA, mRNA, or protein? It's a tricky one. All right, and the answer is
It is mRNA. So most of you guys got that. That's awesome. But yeah, so first, what mRNA is, it's the instructions to make, in this case for COVID-19, the spike protein of the virus that causes COVID-19. And so it's combined and packaged in a lipid nanoparticle that gives your cells the instructions to make the COVID-19 spike protein. And then once your body makes it, then you can develop antibodies to it. So next time you see the COVID-19 virus, your body will already know how to fight it off and you won't get sick. But there are some vaccines that are made with protein. So that was also could be a correct answer. So good job, everybody.
nice. Thanks, Megan. Okay, this is a tricky one. This might take a wild guess. This panelist enjoys cooking and baking. Who do you think it is? All right, put in your guesses, and the answer is
It's me. I see one of you guessed correctly, so congratulations. I love cooking and baking. I love spending time in the kitchen, in part because I think I get to use a lot of my scientific brain and measuring and seeing how ingredients work together, and how caramelization works, or how baking works. But I think what's even more important is just the recognition that as a scientist or as an engineer, you don't have to only do science and engineering. It's okay if you have other interests. You can make time for those interests and find oftentimes ways that your interests inform what you might do in your day job and vice versa.
awesome. That was perfect. All right, here we go. Your next question is, this panelist was a Girl Scout, has a daughter in Girl Scouts, and is now included in the Girl Scouts New Career Exploration Badges. Who do you think it is? This is a tricky one, and the answer is
The answer is me. So yes, I had the pleasure and privilege of being included in the new 24 Girl Scout badges that were actually released in July. So last summer they released these badges really to help, get more girls into science and into a lot of the STEM fields, because only 24% of professionals in STEM are women. So we really need to make an impact on that. And these career badges will be able to do that. So I'm so happy to not only be a part of it, to have my daughter and her friends using it as well, and see myself as well as many of our other panelists and of our other STEM ambassadors that are participating.
Thank you, Aisha. All right, we're on to our next category, which is STEM facts. 3D printing was invented when this panelist was born. Who do you think it is? Put in your guesses, and the answer is
It's me. I think it's so cool that I was born about the same time that 3D printing was invented. I'm not going to tell you how long ago that was. You can Google that for yourself. But it's actually been around for quite some time. When it first was invented, people saw it and thought it was going to change the world, but then the materials just weren't right. And as we talked about before, inventing takes a long time for things to actually work. And so it actually kind of died at that point and then came back to life a few more times. And now it's finally here to stay. But yeah, it's a really neat technology that just keeps growing, and we hope to make it even better for the future.
awesome. Thank you, Amy. All right, our next question. I hope you in the audience have taken some biology for this one. This immune cell is known as a big eater as it eats viruses and bacteria. Is it a T cell? Is it a macrophage? Or is it a natural killer cell? I think it'd be awesome. And whoever answers this, I want to know if a natural killer cell is a real thing, because that sounds pretty cool. All right, and the answer is
Macrophages. Yeah, sorry, didn't mean to scream that. The answer was in their name, because if you break it into two, macro is big and phage is eat. So put it together and big eater. And macrophages, you know how food smells good to us? Macrophages smell bacteria and viruses and think, ooh, need to eat them, just like that. So then they go ahead and eat them. So bacteria and viruses have eat me signals, and macrophages are like, I would love to. And that is how they're able to get rid of viruses and bacteria when you get sick. And natural killer cells are a real thing. I am currently in a fight with natural killer cell Twitter because I keep telling them they're not real cells. Because natural killer cells are so powerful that they only show up when things are super bad, because they're so powerful. So they're not usually found roaming around just like macrophages and, for instance, red blood cells. They only come in when it's like super serious, and then they come in just set everything on fire. But yeah, macrophages, big eaters. They're great cells. They should be your favorite cells.
Awesome. Thanks, Danielle. All right, next STEM facts. How many different types of 3D printing technologies are there? Is it 7? Is it 3? Or is it 1? Put in your guesses. And the answer is
7. I think you all guessed correctly. Most people, when they think of 3D printing, they think of the type of printers that'll print these neat little plastic things. But there's actually a lot of different ways you can build something one layer at a time. You can use a laser beam to melt powder. You can use a welder to add metal layer by layer. There's just a lot of different ways. You can start with plastic powder. You can glue it together with inkjet and get full color parts. So yeah, I've got lots of different fun parts here, but there are a lot of different ways to 3D print, and that's what we study as researchers is, you know, what's the best one for this application, or how could this one be improved to give us unique parts and unique materials. So it's a really, really big field that most people don't know about.
awesome. Thank you. All right, we're on to our next category, which is diversity in STEM. This is the percentage of women earning bachelor degrees in computer sciences. Do you think it's 19%, 55%, or 3%? Let's put in your guesses. And the answer is?
It is 19%. So that means that there's a huge opportunity here for women in computer sciences. So only 19%, according to the information from the National Science Foundation, are able to earn degrees in computer science. And that means that we still have a gap, and that we need to do something, and we need to work harder in order to include more women in computer sciences. So maybe one of you are interested in the near future to know more about this type of science and to be part of this growing women in computer science.
Awesome. Thanks, Gretchen. All right. Your next question is, this panelist is part of the pit crew for the Green Envy Racing, the woman-built world's fastest electric motorcycle. How cool is that? Who do you think it is? Put in your guesses. And the answer is?
It's me again. So this is a really, really cool project that I got to be a part of and still kind of a part of is Eva Hakinson. She's the fastest woman on a motorcycle, and she builds and races the world's fastest electric motorcycle. And what we do is we actually have to go to the salt flats, which is a bunch of salt. It's a very salty lake that dries up once a year. And it becomes this really smooth, flat surface. It's several miles long. The one in Australia that we went to is 8 miles long. And that you need all of that distance to reach these top speeds. So we had to go you know, caravanning into the outback of Australia to get to the salt flat. It's in the middle of nowhere, camping out at a ranger station, and then, you know, working on this motorcycle. It's a streamliner. It doesn't really look like a motorcycle, does it? But it's a streamliner motorcycle. And so working in the desert in the heat, but it was just so much fun. And they're back there. They tried to get back this year, but COVID prevented that. But anyway, it's just a really amazing experience. And you never know what you could get into as hobbies when you're an engineer. There are so many fun things like this you can do. So I look up Eva Hakinson, Green Envy Racing. It's a really, really neat program. She's an amazing lady.
Awesome. Thank you, Amy. Okay, we are on to our next category, which is breaking stereotypes. This panelist failed every timed multiplication test in elementary school. Who do you think it is? And the answer is?
It's me. Yeah, I was never the math person. And we had these time tests where we had to do like 60 multiplication questions in like 60 seconds. And I failed every single one of those. But somehow I managed to that year be nominated for a National Math Achievement Award through elementary school and middle school. So that was just something that showed me that I could still push through things that I wasn't necessarily the best at. Also public speaking in the pictures, giving talks on stages in front of hundreds of people is something that makes me nervous still to this day, but I'm able to, again, push through that fear. And then I love that picture on the right with my dad building the bat houses in 6th grade. And I was afraid of power tools. And I had never used like an electric drill before doing that project. But again, pushing through that and showing myself that I can actually do this. So yeah, just making sure that you're pushing yourself out there and don't let those failures stop you, because you can still succeed even through those.
Awesome. What a very powerful message, Kristen. Thanks for sharing. Okay, the next question is, this panelist was a jazzercise instructor for 10 years. Who do you think it is? And the answer is?
The answer is me. So yes, I taught jazzercise for 10 years, absolutely loved it and still miss it. And it just really goes to show you that even as an engineer, like Amy mentioned, you still have a lot of different hobbies and things that you love to do. And one of the things that I was able to do was really to incorporate my engineering background. While I was in college, I did a lot of research on acoustics engineering, which is the study of, it's the science of it's the study of sound and the science of sound. And so because my classes would be all random different places, I could have a class in the firehouse, I could have a class in the gym, in a classroom. I even had a class in the hospital lobby. And so because of the different places that I had my classes, I had to think about how the sound actually would bounce off of the area where my classes were, because sometimes they were very small spaces, and sometimes they were very large spaces. So I had to think about it. So I was able to use my engineering background and the research that I did in acoustics engineering to make sure that the sound was very leveled in all of my classes. So love jazzercise to this day. Anything that can help you move and get exercise is great.
Awesome, thank you. All right, next question is, and if you were listening, you might know this one. This scientist is also a children's book author. Who do you think it is? And the answer is?
The answer is me. In high school, I loved chemistry and I also loved literature. And when I became an adult, I found a way to marry the two together. So I write the Abby Invents picture book series to encourage girls and boys to become inventors. Abby is a curious girl inventor. In the first book, she's tired of her crayons breaking, so she invents the world's first unbreakable crayons. And in the second book, she sees her mom taking forever to fold laundry, So she invents the world's first at-home laundry folding machine. Now, one of the myths of inventing or becoming an inventor or filing a patent is that you actually have to build the device before you file the patent. But that's not true. You can actually file a patent based on an idea. And that's because the United States Patent Trademark Office changed the rules where it's no longer first to invent, but first to file. And so if you have a really, really cool idea, I encourage you to brainstorm and sort of map out what your invention looks like, how it's going to function, and consider submitting a patent. You never know, you could get Inventor too.
Awesome, thanks. And if you haven't seen these books, they are phenomenal. I love them. Okay, here is your last question. This scientist knows how to drive a motorcycle. Who do you think it is? Put in your guesses. And the answer is...
There are two of us. Here is Greetchen. This is really awesome. I think many people don't realize how many things scientists like as a hobby, right? And we have many different hobbies and many different interests. And one of mine is to have a ride. And I live in Puerto Rico, so it's very beautiful to get in my motorcycle and then go around and see the beauty of the island. So I really love to do this, and I have many other hobbies too. So I encourage you to always pursue whatever you like, and you will always have time to do all these things, even if you're a scientist and engineer. Amy.
So I, in the off-road version, I really enjoy dirt biking. Me and my husband have a few dirt bikes, and I just really love off-roading. We have some beautiful mountains here in East Tennessee that we can go explore with the dirt bikes. So, but yeah, it's really fun. I mean, just because you know, you have this STEM career doesn't mean there's more to it, more to you than just your career. We have a lot of interesting hobbies, I think.
Awesome. Thank you, Greetchen and Amy. All right, so this concludes our Jeopardy game. So what we're going to do is I want you to start thinking about any questions that you may have for our panelists, and I ask you to please put them in the Q&A box, not in the chat, but in the Q&A box, okay? And as you're thinking about those and popping them in, I'm going to ask the panelists to share some of the best pieces of advice that they have for young girls that are interested in pursuing STEM. So go ahead and pop in if you have anything to share.
I think you should call us out, Paula.
Yeah? Or else everyone's going to talk at the same time. All right, Danielle, the floor is yours, Danielle. You go first.
No, I set myself up for that.
Yes, you did.
I just want to say that a lot of the panelists have said it, but STEM is everywhere. So you shouldn't think that you have to do it a certain way to be right. The entire point of science, technology, engineering, and math is, and also art, is that they're questions. They're questions, and if you have a question, ask it. And if you ask it, are you willing to design the experiment to answer it? Because you never know if your answer is what's going to change the world. And when I say change the world, I don't mean, oh, change the entire, the entire planet. But if all of us are changing the world in our small little parts of the world, then we're all affecting change, right? So if you have a question, ask it. I always say, people say, oh, this might be a silly question. There's no silly question. A silly question is one that isn't asked. So ask it anyway, because after you get the answer, you're better for it. So please don't be scared to ask any questions. And if you think you can solve it, go for it. Don't let fear of not solving it stop you from doing it. As Arlyne was saying, it takes a while sometimes to get an answer, but once you get the answer, oh, it is quite the feeling. So don't be scared to ask questions and change the world, please.
Awesome, Danielle. Amy, did you have anything you wanted to add to that?
Yeah, I love what Danielle said. And then also just staying hands-on. Like, I know one thing that really kept me motivated. So, it's no secret that, going to school for STEM is a challenge. It can be really hard sometimes. It's totally doable. And one of the things that really helps me stay focused and remember why I was working so hard and staying up late and studying was it's fun. And at the end of the day, you know, when you get to be in the lab or you get to work on a machine or you get to invent something, that's why you're doing it. And just so staying hands-on, join clubs, always, you know, have a little workshop where you're working on your inventions, building things, get a 3D printer. That's the hands-on stuff that you get to do after you get out of school. But in school, it kind of makes it, you kind of forget if you don't do it on your own.
Awesome. Thank you, Amy. Gretchen, did you have anything you wanted to share?
Yeah, I just want to add something that I think is very important, and is that don't let other people to define success for you. Don't try to, to fit into a box of what is the definition of success. I think you can create your own, and then you'll see how things will go even better. And I think success is subjective, so it's like beauty. There's no exact and correct definition for that. So do your own.
Very true. Very true. Wise
Paula.
words, Gretchen. Yes,
Paula,
go
there
ahead.
are questions in the Q&A box.
Yep. We're going to get to them. I just want to make sure I'm not missing anyone. Hold on. Megan, is there anything that you want to add in terms of a piece of advice?
Yeah, I'd say from my experience, especially in what everybody has said here today, there's no one way to do science or to be a scientist. So you don't even necessarily have to go to school in a STEM degree to be a to do science, like cooking is science, being a mechanic is science. So it don't have to be limited by what you think of as a traditional science career. And same for, you don't have to be limited by what people think a scientist is. You don't have to have certain interests or certain, things about you. You can, take your unique specialties and turn that into an interest and be the person you want to be in science or outside. So don't let anybody define who you are, what you can be, and just do what you want.
I love that. Thank you, Megan. Awesome. Afua, is there anything that you wanted to add?
Yes, thanks for asking. I would just encourage people to recognize that it's okay if your interests evolve or completely change over time. I know growing up, I wanted to be a tennis player at one point. I wanted to be a teacher. And then even within STEM, I wanted to be a microbiologist, an anesthesiologist, and a marine biologist before finally settling on computer engineering. And what I've done since graduating, I started off as a software engineer. But now I work with data scientists and do a lot in the nonprofit space and really giving people access to public goods. So it's okay if your interests evolve over time, and that's fine. You don't have to know exactly what you want to do 5 years from now, 20 years from now. And if your research interest or anything else looks like it needs to go in a different direction, that's okay too.
Love it. Thank you. Kristen, anything that you wanted to add?
Yeah, I think for me, one of my key things growing up was that it's never too early to get started in whatever you're interested in. I remember I've always loved animals. I thought I wanted to be a vet or a wildlife vet originally, but then kind of discovered bats. And I just remember I read so many books about animals. Now we have the internet and YouTube and social media where you can find all this great information about whatever you're interested in. So I think just, consuming that information and just starting to learn, attending talks and presentations like this and events, it really never is too early to get started. So I think that's my nugget of wisdom there.
Awesome. That's a great nugget. I love it. Arlyne, anything that you wanted to add?
Sure. The one thing I would like to add is, often we compare ourselves to experts in the field, but remember that every expert started off as a beginner at some point in their life. So don't compare where you are today with, someone like Albert Einstein. You have to start from somewhere. So it just starts with one step, and eventually you'll get to exactly where the universe would like to take you. So be patient with yourself.
Awesome. Great. And last but not least, Aisha, is there anything that you wanted to add?
Yes. Yes, thanks for asking, Paula. I would just say, even if you're not interested in pursuing any of these fields, just try different activities and projects because you never know what you may be gravitated to. You have no idea, but if you don't try, then you won't be exposed to the opportunity that you could have possibly missed. So just give it a try and just see if you like it, and then you can at least eliminate things that you don't like so that you can focus on things that you really like. And then the other thing I would say really quickly, as well as I think one of the other panelists said it, but try to really turn things that you're passionate in to your career. If you like cooking, there's an aspect of that that you can go into engineering. If you like playing video games, like whatever it is, really try to turn, because you really want to wake up every day and love what you're doing.
Awesome. Thank you. All right, let's get to your questions. So while we're answering your questions, I'm going to leave this up here. So again, you have our information. You can reach out to us directly if you have any specific questions for any of us. The other thing I want to give you a heads up on is that I actually do have prizes to give out. And so to enter for a chance to win a prize, please go to the testimonials section of the Atlanta Science Festival website and share what inspired you most out of today's session. And please, please, please include the hashtag STEM women, hashtag STEM women, so we can easily find it. Okay, so go into testimonials, put in what inspired you most, and out of there, I will be picking out prize winners, and you will hear from me directly. Okay, so without further ado, let me get to your questions, and please feel free to keep them rolling in. We've got enough time to answer a lot of questions. Okay, so I have a question on, I am interested in going into biostatistics. What post-bachelor classes can I take? Biostatistics. Does anyone have any feedback on that from the panel?
I can take a stab at that. So it depends on the classes you took in college. So if you didn't have any biology or statistics classes in college, then of course your post-bac should focus on those classes in addition to chemistry and physics. Because I don't know what programs, I don't know whether you're applying to go to med school or you're planning to go to graduate school, but look at the schools you want to apply for after post-bac, and then look at the classes they require, and then use that to inform the kind of classes you take in your post-bac. That's the only way, I think. That's the best way I think you can be able to tailor your post-bac towards whatever advanced degree you're aiming for. So I hope that helps.
Yeah, I think that's somewhat helpful. She also responded back that she is looking into the School of Public Health. So maybe there's some interesting information that can come from this panel with that piece of information as well.
Yeah, I think the best way is always look at put down a list of the schools you're looking to apply to. They will tell you what they want you to have. If you try to guess it, it's really not going to work. So look at what they want and then tailor your experience towards that so that your application is stronger and will stand out from other candidates.
And I will say to just follow up with that, I know a lot of for statistics, it's also the tools that you use to do statistics. So taking classes like R classes or whatever software that your department uses. So those are always really great to get training in those kind of tools.
So I'll jump in. I know I'm an engineer, not a biologist, but my sister is an epidemiologist. She got her master's in epidemiology, and there's a lot of statistics in there as well. So if you're looking into like public health, epidemiology is a really great field to get into.
Awesome. Okay, let's move on to the next question. The next question we have is, when did you start your job? And this is a question for everyone. When did you start your job? Maybe this is a good lead in into, kind of the transition from school into job. And I'm sure some of you have PhDs and so forth. So I think we can get a variety of answers here on when did you start your job?
I can start, and maybe others on the panel can jump in afterwards. I started my most current job just about a year ago. It seemed like a good move for me just to continue to get closer to the types of work that I wanted to do. Whenever I look at taking a new job or starting a career, I try and figure out what skills do I have today and what do I like doing with where I am now, and what else would I like to be doing, and use that to help me decide to make a job transition. My first job in engineering, though, was while I was an undergraduate student. I co-opted, and so I worked every other semester full-time at IBM all through undergrad, and then took a full-time job at IBM as a software engineer after graduating from undergrad.
And I'll jump in. Similar to Afua, I actually did co-op as well. So I worked every other semester while I was in school. So that gave me a lot of experience. And I did my co-op at a consulting company, which was really cool because I worked for the consulting company, but they would contract me out. So I got to go to other companies. And I thought of it as like kind of being a spy, because it's like you work for a company, but you get to see what's happening in other companies. So it was really cool. And I got to travel internationally as well. And then when I graduated, they made me an offer. And so I started right after college. And one thing I'll say is that I wasn't really talked to a lot by my professors and faculty about going to graduate school and doing research. So it was years later that I actually went back to school and went to graduate school. So just, really be open to, when you go to college, all of the different options that you have. You don't have to just go straight to work. You don't have to just go straight to graduate school. There are a lot of different options and opportunities.
I'm gonna continue piggybacking on this question here. So my first job in the US was as a pharmacy technician at CVS Pharmacy. I was a sophomore. And since I was a chemistry major, I really wanted to understand the different opportunities that there were with a chemistry degree. And so at first I thought being a pharmaceutical engineer or pharmacist would be cool. And so for me, most of my early jobs helped me realize what I did not like to do. So I learned very quickly I did not want to be a pharmacist. And then my first two internships helped solidify that I did not want to be a chemical engineer. One was working in a chemical plant. They had me climbing these towers and I was afraid of heights. Another one had me, in a lab working by myself. And I realized what I liked reading a lot in my spare time was really healthcare technologies. And that's when I pivoted to be a biomedical engineer. So I think Afua mentioned, recognizing that you evolve with time. And so I think at every step of your journey, you start learning what you like, what you don't like, and slowly you start getting exactly where you'd like to be.
I'll just tag on real quick, but my career journey so far has been an example of how fluid STEM is, having a STEM degree is, because I originally, when I was in college, I was actually studying to become a marine biologist, and then took that and went into cancer immunology. And my first job after graduate school was working in magnetic levitation, which is physics. I can assure you that I did not do a physics degree. That's a fact. Somehow got a physics job. And what we were doing was we were using magnetic levitation, which I promise is not fake. I honestly thought this company was having me on. I said, there's no way you guys have figured out magnetic levitation. It was in Wakanda. Who has time for that? But they were using magnetic levitation to separate cells, because the cells in our bodies, they have different weights. So you can actually put them in a system and take advantage of the different weights to separate them. Because whenever you have to take a drug or anything like that, when they test these drugs, they test them on specific cells first to make sure that they're targeting the cells they want to target before they test on the whole body. So that's the use of that kind of thing. And so that's where my first job was in understanding the physics of magnetic levitation and how to use it in biology, in cellular biology. So it's that fluidity of having a STEM degree. And my current job, I've been here, I think about 8 months. Also, I got it during the pandemic. And I'm back to doing cancer diagnostics, but so far away from what I studied, because I studied if you think about, I don't know if you know this, but in cancer, you can divide a tumor into two. There is the actual cancer cells, and then there are the cells that are around the tumor. I studied the cells around the tumor. I currently work in a company that studies the tumor. So once again, far away from what I've learned, but because I understand what happens around the tumor, I can take that knowledge and apply it to what happens in the tumor. So that is the power of a STEM degree, is you can take knowledge from one aspect and apply it in another field.
Yeah, and I'm going to piggyback off of Danielle because I know my goal today was to really highlight and showcase all my amazing friends to all of you. But Danielle brings up a really good point, because I was a chemical engineer. I worked in chemical engineering for a decade. And then 8 years ago, I made a switch, and I'm in a business role now. So I'm a strategic marketing manager, and it's a completely different job. I never went to school to get an MBA, never took business classes. But to Danielle's point, if you start with a very strong STEM background and a STEM foundation, that can lead you in a lot of different directions. If you can do STEM, you can learn a lot of things along the way as your career progresses as well. So I think Danielle brought up a really good point about how, the fluidity of STEM and all the different ways that you can use STEM. And I think a lot of us are examples of that, how we started in one area and now we're working in a completely different area than where we started. Okay, so I know we're coming short on time here, so I'm going to just do one more question. This question is for you, Afua. What is your day in the life in the field of data science? What does that look like for you?
Thanks so much to whoever asked this question, to Priyanka for asking this question. So as I mentioned, I work at an organization where I work with about 20,000 volunteers around the world who are all expert data scientists donating their time. And so a day in the life for me as a data scientist looks like finding an organization who is trying to make the world a better place. So we've worked with food pantries, we've worked with people who deliver medicine, we've worked with people who make sure their water quality in a particular area is high enough. And we've worked with people who make sure there's enough water that will get to everyone in a particular area. So a day in the life for me looks like finding those organizations, really working with that organization to figure out what's their actual problem. Not just what they may say their problem is, but what's the problem behind the problem, and what does everyone who touches that problem actually think about it and need. It's really important before you start designing a solution to make sure you talk to the people who are going to be affected by the solution, and you don't just come in with your own ideas. And so in that process, we define also what data is available to help solve that problem. So if it's delivering medicine, for example, it's how many delivery people do you have? How long are their delivery routes now? How much does it cost to fill gas tanks, and how much does it cost to pay people? And then we use a variety of algorithms, all sorts of data science algorithms, from natural language processing to matching algorithms and everything in between. We often use Python is my preferred language. R is another language people like. So we define those algorithms, we do some testing, and then we work with the organization to actually implement it. And then again, talk to a bunch of people to make sure that it works, that we can go back to that data and we can see how we can quantify what actually improved, and then make sure by talking to people that we didn't hurt anyone in the process of what we did.
Thank you so much. That was great. All right, so I think we're up against time. So once again, I want to thank our amazing panelists for being here today. I want to thank everyone in the audience who's able to join us today. And I'm very hopeful that you learned a little bit, you took a little bit of wisdom with you today. Again, thank you to the Atlanta Science Festival for hosting us as AAAS If Then ambassadors.